Okay, so the first question was, we had a gold medal in the Olympic Games consisted of 89 grams of silver and only actually 6 grams of gold. So the first question was, what is the value of the gold medal in monetary terms? Only how much was it worth? We know that silver costs 1.5 kronas per gram, so they've been really nice here in giving you the pricing in grams already. Usually it's more usual to express it in kilos. So we take our amount of silver, which is 89 grams, and multiply it by the price per gram, times 1.5 kronas per gram. Kronas per gram. We can see here that when we're multiplying grams divided by grams per kilo, that the grams will disappear, giving us an answer in kronas, and that's what we're expecting. So putting the units in makes it really useful here. Okay, so we then have that equals 133.5 kronas. And that's where I made my first mistake. I punched the wrong numbers in and didn't get that. But because I punched the numbers in again, I found my mistake and then was able to correct it. 6 grams of gold at 132.25 kronas per gram will give you 793.5 kronas. So the amount that the silver, the large amount of silver, was actually only worth 133 kronas. And the amount of gold, that's only 6 grams of gold, was actually worth 800 kronas. But we wanted the total price of the medal, so we add those two together, and we get 927 kronas. So the medal was worth, don't forget to answer the question well, 927 kronas. Okay? Could also have had a formula here that you take the weight of the medal multiplied by the price per gram. So you could have actually had a nice formula in there as well. So that was just 2 points for that. One is probably for getting each of those one, and the other is for getting, or for getting one of them right, and both of them is for getting the whole thing right. Then we have different prices of tickets if you go to the Olympic Games, and they tell you that €1 is equivalent to 9.3 kronas. So we can think of this as being any other conversion table that we would have. To go from euros to kronas, we would multiply by 9.3. And if we were going from kronas back to euro, we would divide by 9.3. So, and then they say to us, what would it cost in Swedish kronas if we went to the opening ceremony and we sat in the most expensive seats, because they are category A. So we have to look at the table and we have to say, where's the opening ceremony? It's here. Where's the category A seats? It's here. And then we have to convert that into euros. So 850 euros for category A opening ceremony. Price in kronas equals euro price times 9.3. So we get equals 8,500 times 9.3, which gives us 7,905 kronas. So if you wanted to go and have best seats in the opening ceremony, it was almost 8,000 kronas to do so. Yep.
It's 850, not 800.
850.
It says.
Yeah, sorry. Yeah, thank you. Then it says, question B, how many % more expensive is it to buy a ticket for figure skating in category A compared with category B? So if we're going to look at figure skating for category A, it was 300 euros. And figure skating for category B was 100. So these are the two we are going to look at. And we know that the formula for percentage change is the difference between the two prices divided by the price you're comparing to. And it says compared with category B. Okay? So that's the one that should be on the bottom. Super important here that you put the right one on the bottom. And it's always the one that's after compared with or compared to. So the one that comes after that word, jämfört med, that's the one that's on the bottom. So here we would have 300 minus 190 divided by 190 times 100 to change it into percent. And then we would get 57.9% to one decimal, which is approximately 58%. More expensive. So don't forget to answer the question. A is 58% more expensive than B. Okay, and then that's finished with, we don't need the table anymore. Then after that, we are looking at tricks on a snowboard. And the question is, how many turns is a 900 degree turn? In order to be able to work that out, we have to remember that one turn in a snowboard, so if you've got your snowboard and you're doing one turn all the way around, flipping 360. One circle is 360 degrees. Okay? So the way that we get what a 900 is the number of degrees that you turn divided by the number of degrees in one full turn. Which is always 360. So we take our 900 degrees, so number of turns equals 900 degrees divided by 360, which, hey presto, turns out to be exactly 2.5 turns. So this snowboarder goes around once, flips twice, and then ends up going backwards. Okay? So 2.5 turns. Then there was actually not enough snow at this Olympic Games, so they actually had to import snow from other places. What do we know? We know that they transported 3,000 cubic meters of snow. And question A was, if they transported 3,000 cubic meters of snow and one lorry can take 15 cubic meters, we have to do some planning here. This is how much snow we need. How many lorries are we going to need? Or how many trips on each lorry? Okay? So in order to get that, we need to know amount of snow, which is in meters cubed, divided by amount that a lorry can take, which is in meters cubed per lorry. The meters cubed cancel and we get 1 over 1 over lorry, so then you get the number of lorries. So we need to calculate 3,000 meters cubed divided by 15 meters cubed per lorry, which will give us 200 lorry loads. So 200 lorry loads of snow is what you'd need to get 3,000 cubic meters along the track. Then they said, right, giving you the dimensions of the track here. The track is L equals length equals 4 kilometers long. The breadth of the track,
No, it's 5.
oh, 5 kilometers long, sorry, was 5 kilometers long. The breadth of the track was 4 meters wide. We know the volume, V equals volume, it's 3,000 cubic meters. They're wondering what the height is going to end up being. In order to do anything with this, you can't do anything unless you've got everything in the same units. Here we have a unit of meters cubed, which means that anything that is going to be in our calculation has to be in the terms of meters, unless we change the volume unit. That's not a good one to change. It's much easier to change everything else. So here we have meters, here we don't have meters, but we can convert kilometers to meters. Equals 5,000 meters. Now we've got meters, meters. What are we going to get our answer in? We're going to get our answer in meters. So what's our formula? Our formula is volume is length times breadth times height. This is the one we don't know, so we isolate it. Move everything else over to the other side. Divide both sides by LB. L times B. So we get V divided by LB equals LB divided by LB times H. This one cancels. So we now know that the height is going to be the volume divided by the length times the breadth. Okay? Which is 3,000 divided by the length, which is 5,000, multiplied by the breadth, which was 4. So the zeros cancel here, giving us 3 divided by 20, which is 0.15 meters. Let's just do a quick check that we've not made a silly mistake anywhere. Let's put our units in here. 3,000 is in meters cubed, and our length is in meters, and our breadth is in meters. So meters cubed divided by meters squared will give us the answer in meters. So putting the units in helps make you realize where you could have made a silly mistake. So it's very important to do. Then we have the next question. And here's where a little sketch is quite useful. We have a height difference of 500 meters. So if we're starting here, and we call this one 0, 100, 200 meters above, 300 meters above, 400 meters above, and 500 meters above. So this is where we're starting, our skier, and he's coming in the goal here. And we know that at this point here, the temperature is -2 degrees. And it gets half a degree colder every 100 meters he goes up. So this one will be -2.5.
No, it's fine.
This one will be -3 degrees C. This will be -3.5 degrees C. And this will be -4 degrees C. And this will be -4.5 degrees C. So that's a sketch way of doing it quickly. A mathematical way of doing it quickly will be the start temperature plus the temperature difference times the interval. So we started at -2 degrees, and we have a temperature difference of -0.5 degrees times the interval. We have 5 different intervals going from 0 to 500. So we'd get -2 degrees centigrade. -0.5 times 5 will give us -2.5. So we get -2, -2.5, giving us -4.5 degrees centigrade. So the temperature at the top, where the player starts, is -4.5 degrees centigrade. Then the last one on this paper is that there is a formula for size of your foot, where the size of your foot is 3 times the length of your foot in centimeters plus 5 divided by 2. S is shoe size, or pied size, and X is length in centimeters. First time around, they tell you that Anna's foot is 23 centimeters long. So they want to know what size of pied she's going to have. Well, she's going to have 3 times 23 plus 5 divided by 2, which will be 69 plus 5 divided by 2 is 74 divided by 2, which is 37. So Anna is going to have size 37 is the first answer there. Size 37. Then the next one is they tell you that Eric buys size 42. What's the length of Eric's foot? Well, we're going to get that 42 is 3x plus 5 divided by 2. Multiply both sides of the equation by 2, you get rid of the divide 2 there. So you get 42 times 2 equals 3x plus 5. Move the plus 5 to the other side, so you get the 84, because 42 times 2 is 84, minus 5 is 3 lots of x. We now know that 79 is 3x. So if 79 is 3x, x is 79 divided by 3, which is 26.3 recurring centimeters. So you should say that the answer, that Eric's foot is around 26 centimeters, or anywhere between 26 and 26.5, but not rounding up to 27. We'll give you the correct answer there.